Okay, so before we start on chapter 2, okay, so let's do some revision, okay, relating to DC motor. Okay, because of chapter 2, it involves on how to control the speed of DC motor. Okay, so let's start with type of DC motor. Okay, so DC motor, DC stand for direct current. So direct current motor, okay, divided based on its excitation. Okay, either self excitation ataupun self excited, ataupun second one is separately excited. Okay, for self excitation ataupun self excited is divided into three types of motor. Okay, series, compound and shunt. Okay, series, compound and shunt. Okay, so for separately excited DC motor, this is the circuit representing the separately excited DC motor. Okay, we have field circuit. Okay, this is field circuit, and then this is armature circuit. Okay, armature circuit consists of RE and EE, and then this is our voltage supply, V terminal. V terminal. Okay, so one more thing you have to know that for separately excited DC motor, okay, IL, which is our line current, is similar with IE. Okay, IL is similar with IE. Okay, okay, and then for separately excited DC motor, okay, it use two different source. So ini adalah VT, ini adalah VF. Okay, field voltage. Okay, dia boleh jadi sama value. Okay, boleh jadi dia tak sama value untuk VT and VF. Okay, so next one is shunt. Okay, shunt DC motor. Okay, so we have sama juga, we have field circuit. Okay, this is field circuit, and then this is armature circuit. Okay, RA and EE. RA and RE ni we call field circuit lah. Sorry, armature circuit. Okay, kenapa shunt? Okay, kenapa shunt? Because of this circuit is parallel between armature and field. Okay, between armature and field dia adalah parallel. So shunt ni actually nama lain bagi parallel. And then this is VT. Okay, so this one is IL. Okay, line current. So line current ni dia tak sama dengan armature current. Okay, kalau you draw this direction of current ni, so I line ni dia akan divided into two. Satu kepada IA, and then satu lagi kepada IF. Okay, IA dan IF. So ini adalah terminal voltage lah. Okay, this terminal ni, okay, you have you boleh assume sebagai kita punya datang daripada utilities, which is for Malaysia comes from TNB lah. Okay, itu adalah kita punya VT, V terminal. Okay, so kenapa saya letak dua je, separately excited DC motor dengan shunt? Okay, because of most of the example yang kita pakai untuk chapter 2, okay, selalu dipakai untuk separately excited lah dan shunt. Okay, dua types of motor ni je. So types of motor yang lain kita tak cover in our syllabus. Alright, so okay, yang ni okay, revision untuk calculation. Okay, so saya terangkan sikit lah. Okay, for those yang dah tak ingat. Okay, so let's read the question first. Okay, 240 volt, 1000 rpm, 25 ampere separately excited DC motor has an armature resistance of 0.6 ohm and the field resistance is 220 ohm. Okay, determine the power delivered to the load and torque produced by the motor. Okay, so first thing first, okay, bila dapat soalan motor, you have to identify what is the types of motor used. Okay, bila okay, different types of motor ni dia akan bagi different result yang berlainan lah. Okay, so for this motor, okay, for this motor, okay, dia pakai, for this question dia pakai separately excited. Okay, so you can draw the diagram first. Okay, for separately excited, okay, we have RF, VF, and then this one is okay. Okay, so this VT, RA dan EE. Alright, so this is I line. So as I mentioned earlier, untuk seperti excited, okay, I line will be equals to IA. Okay, dia akan sama dengan IA lah. Alright, so the first question is determine the power delivered to the load. Okay, so remember back the formula for power, P equals to EA, IE. Okay, EA is armature voltage, IE is armature current. So the parameter that we going to determine first is EA. Okay, based on KVL, okay, negative, positive, okay, positive, negative. So negativity plus IA RA plus EA equals to 0. So you can rearrange this equation in terms of EA. So EA equals to VT minus IA RA. Okay, so VT equals to 240 volt. Okay, parameter yang dia bagi ni adalah semua dalam rated lah. Especially voltage dan current. Sebab voltage dan current ni come from utilities lah. Okay, so 240 minus IA. So IA in this case dia akan sama dengan IL. So IL is 25 multiplied by RA is 0.6. Okay, so you can calculate the value for EA 225 volt. Okay, so this the value for EA. Then you can apply this formula to determine P. So P equals to EA 225 multiplied by IA, which is similar to IL, multiplied by 25. So dia akan dapat 5625 watt. Right, so next one, the torque produced by the motor. Okay, the torque produced yang ni lah, torque kat sini torque yang diproduce dekat load ni. Okay, so remember the formula is P come from P equals to T omega. So remember this formula, P equals to T omega. So we rearrange in term of T equals to P over omega. Okay, and okay, bila melibatkan torque ni, ada je equation torque, ada parameter torque. Okay, speed ni mesti dalam radian per second. Okay, so you have to convert 1000 rpm into radian per second lah. Okay, untuk this one, P equals to 225, okay, divide by omega. So 1000 multiplied by 2 pi over 60. And this one adalah conversion formula for RPM to radian per second. So the torque get is 53.71 Newton meter. Okay. Okay, so next we move on second example. Okay, this is the first one and then this is the second one. Okay, so the parameter given sama the value yang given for the first and second question tu sama. Okay, VT dia adalah 240, speed 1000 rpm. Okay, the current is 25 ampere IL, but the type of motor is different. For this one, okay, I use shunt DC motor. Okay, so kita nak tengok dia punya beza dia punya beza bila we use the different types of motor. Okay, so firstly you have to draw the connection, the diagram for shunt motor. Okay, we have RA, EA, and then shunt dia akan parallel lah dengan di circuit. So this is VT. Okay, this is IL, RF, RA and EE. Okay, this is IA, IF. Okay, sama juga the same formula that we going to use. KP equals to EA, IE. So the first parameter that we going to determine is EA lah. Okay, EA, the formula is VT minus IA, RE. Okay, but for this question, okay, IA is not similar with IL. Okay, so you have to find the value for IE lah. Okay, so how to find? Okay, because of VT is 240, which is parallel with RF. Okay, so the voltage across RF is also 240. So you can determine IF. Okay, IL minus IF. Okay, and then we can get IE lah. So IE equals to, okay, IL, okay, minus VT divided by RF. Okay, so IL is 25 minus 240 divided by RF is 220. Okay, so you can calculate the answer. Okay, 23.91 ampere. Then we can proceed to this equation. VT is 240 minus IA 23.91, RA is 0.6. So EA is 225.65. Okay, and then you can back to this formula to determine P. Okay, 225.65 multiplied by IA is 223.91. So the answer you get is similar with the dalam slide tu lah. Okay, 5,395.4 watt. Okay, 5,000. Okay, 5,395.4 watt. Okay, and then for torque, okay, similar equation, T equals to P over omega. Okay, P is 5,395.4 divided by omega 1000. Okay, 2 pi over 60. Okay, to convert from RPM to radians per second. So torque is 51.52 Newton meter. Okay, so even though the parameter is similar, okay, the voltage source, the speed and the current, but it gives different value if we use different type of motor. Okay, so be careful when you answer the equation lah, either shunt ataupun separately excited. Okay, dua ni je yang we cover for our syllabus. Okay, just simple So you guys can buat balik lah, practice balik, remember balik okay, last semester punya subject. Alright, thank you, that's all.